Hello, Algebra 2, and welcome to part 2 of lesson 3.5, finding zeros of polynomial functions. So our essential question remains the same. We're going to talk about how the zeros of a polynomial function are related to a function's equation and graph. Today we're going to look at an application problem, and then we're going to look at solving an equation. So here is our application problem. Acme Innovations, they make and sell lamps. It looks like lava lamps. That's spicy. Their profit, P, in hundreds of dollars earned is a function of the number of lamps sold, X in thousands. Anyhow, we've got a model here and a graph for this company's profit. So the way that we interpret this graph, as far as that goes, is right? If it outputs profit, right, then my y coordinate is profit, right? So everywhere, so in between here and here, I guess I could write it like this, right? The profit is negative. They're losing money. In between this value and this value, though, they are making money. And in fact, right here is our maximum profit, if we're going to be interpreting this graph. So that would represent maximum profit for X lamps, right? So you might be able to estimate that 1, 2, 3, 4, right? That maybe when they're making 4,000 lamps is when they maximize their profit. So that's how we would estimate that. We would see that the profit goes to 0 when they're making 1, 2, 3, 4, 5, 6, 7,000 lamps. That's how we would interpret that. But to answer the question, we're being asked, what do the zeros of the function tell me about the number of lamps that Acme Innovations should produce? Well, the fact that there is a 0 at x equals 3, right? So I was pointing out this one. And there is a 0 at x equals, I believe I said 7, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. My bad. X equals 10. The way that we would interpret that is that the profit is positive for values for between values of x equals 3 and x equals 10. So in other words, when Acme produces between 3,000 and 10,000 lamps, the company makes a profit. And I would look at that as a sufficient answer. Other things that you can point out are that the profits are negative up until they create 3,000 lamps. You could also say that they lose money when they create more than 10,000 lamps. But I think this is probably the best answer, right? In terms of how many they should produce. They should always produce between 3,000 and 10,000 lamps, or else they will lose money. Our last example that we're going to be looking at is going to be solving a polynomial equation. So let's go ahead and just get this thing going and tackle it. The same thing that we need to do with solving a quadratic equation is what we need to do for a polynomial equation, and that is that we need to set it equal to 0. We need 0 on one side of our equal sign, and we need everything else on the other side. So what I'm going to do actually is I'm going to move everything over to this side just because I'll wind up with a positive leading coefficient if I do so. So that's my plan starting out. So let's go ahead and subtract 2x cubed from both sides. 5x squared minus 3x equals 2x cubed, right, when I subtract. Just wanted to show that first step working out, and then I'm going to actually do a couple steps at once. Go ahead and move everything over there immediately. All right. So let's go ahead and subtract 5x squared from both sides. So I'll have this 2x cubed. 8x squared minus 5x squared is going to be 3x squared. And then I'm going to add 3x to both sides. There's no x term, so it's just going to move it essentially. And then I'll drop down the 1. And there we go. We've got that thing set equal to 0. All right. Oops. I guess I am not the best at adding and subtracting today. Because this should be number 1. This should be that should be a 1, my bad. And so that should be like that. Sorry, when I subtracted the 2x cubed from both sides, for some reason I did not change it to a 1x cubed. So we need to figure out what values would we plug in for x that would cause this to be 0. And what I'm going to do, that can be really tricky. So what I'm going to do is go ahead and use a tool to help me figure out what this 0 is. I'm going to graph it using my graphing calculator. All right, so there it is. I get out my calculator and I hit the y equals, and I went ahead and entered the function into the calculator. I'll hit graph, and we'll see that there is, it looks like there is an intercept at x equals -1. X equals -1. So I suspect that x equals -1 is a solution. Let's check it. Let's make sure. All right. So essentially, if I plug in -1, or I can check it actually. That's not really the right notation. I'm checking to see if I put -1 in here, do I get 0? Let's see. -1 times -1 times -1 is -1. 3 times -1 is -3. Ooh, that's squared. That's squared. So 3 times +1 now. Plus 3 minus 3 plus 1. Indeed, x equals -1 is our solution. It's the only solution where it crosses the x-axis. We could find out if there are imaginary solutions as well by dividing by the quantity x plus 1, but that's not going to be necessary in this case. So my recommendation, if we're going to be solving these, go ahead and get this thing set equal to 0, graph it, find where it crosses the x-intercept, and that is going to be your solution. Hey guys, thank you so much for watching your lesson 3.5 video today. I hope you're having a fantastic day, and if you're not, man, I hope it gets better. Thank you so much. Take care of yourself.